Today's daily LeetCode problem of the day is split a string into the max number of unique substrings, number 1593. For this problem, we're given a string S, and we want to return the maximum number of unique substrings that the given string can be split into. So, we can split a string S into any list of non-empty substrings where the concatenation of the substrings forms the original string. However, we must split the string such that all of them are unique. So if we look here at example 1, we have the string AB, AB, C, 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 and we can't split it like AB, AB, C, 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 because we have duplicates in the substrings A and B. A optimal and valid solution would be A, B, AB, C, C, C. That way we never have a duplicate substring, even though we have duplicate characters. So that's a way that we can split it while maintaining a unique substring value. So for this problem, we are going to split it a maximum number of unique substrings. We're going to use a substring, and once we use that, we can't reuse it. So with this information, we're going to use recursion and backtracking to make sure that we don't reuse already used substrings. And by using backtracking, we can find the maximum number of unique substrings while simultaneously going through each possible substring. So our approach to this backtracking method is we're going to split the substring at every possible position. At each step, we'll track which substrings have already been used to make sure that they stay unique. And then if we reach the end of a string, we compare the number of unique substrings found so far with the maximum we've seen and update the result. This recursive process helps us explore all possible ways to split the substring, and backtracking ensures that we don't miss any potential solutions. So let's jump into the code and I'll walk you through how we're going to solve this. First thing we're going to do is we're going to return a helper function called backtrack, and it's going to receive 3 different items. So this backtrack method is going to be a recursive method, and we're going to pass it our starting string. We're going to pass it the initial index, so 0, and we're going to pass it a new hash set. So we're passing this new hash set as we have not yet identified or initiated a hash set, but in our recursive process, we're going to want a hash set to be recursively processed. So in the max unique split method, we're calling to a helper function called backtrack. This function will try to split the string from index 0 and keep track of substrings we used so far. So let's now write the backtrack function. So our base case, first let's identify it. So private, it's going to return an integer. It's called backtrack. It's going to receive a string S. It's going to receive a integer start, and it's going to receive a hash set string, and we'll call it used. So we're going to store all of our used hash sets, or our used strings, in this hash set. So let's break it down step by step. First thing we're going to have is our base case. So if we reach the end of the string, we're going to return the size of our used set, which contains all unique substrings we found so far. So if our start value is equal to s.length, so the end of our string, we can return used.size. And used is going to contain all of our possible substrings. Then we're going to loop through all possible splits starting from our current index. So we'll initiate a counter, so int max count, which is going to keep track of how many possible substrings we can make. We're then going to loop through every possible position starting from our start. So for int I is equal to start plus 1, I, as long as I is less than or equal to s dot length I plus plus. Now we are going to turn our substring into a variable. So we're going to have a string called substring, and that's going to be equal to s.substring from start to I. So remember, when we're using substrings, if our start is 0 and our I is 1, and those happen to be the characters A, B, 0, and 1, because the substring goes from 0 to 1, it does not include 1. So our first substring will always be one letter long, even though we have two different variables here. It goes up to, but not including I. So after we initiate this variable substring, we can then, for each split, so for this substring, we're going to check if it's already been used in our use set. So we're going to add it to the set, and then recursively call the backtrack function with the next part of our string, if it hasn't already been used. So if not use.contains our substring, then we can add it to used. So use.add substring. We can recursively check if the next part of the string will add more to our count. So max count will equal math.max of max count or backtrack of S, I, and used. So this is creating another substring, and we're going to recursively make new substrings until we reach the very end of our string, which will then come back, and therefore we'll be using backtracking. So our backtrack part of the method is after we have checked how it will correlate in the long term, if it will update our max count or if max count will stay the same based off of making this substring. We can then remove use.remove this substring. We will then increment I by 1, so now this substring will be of length 2, and then we'll do the process again, ensuring that we always get the maximum amount of substrings. We will then return our max count. So after the recursion, we remove our substring, so use.remove, and that's our backtracking step. We'll keep track of the maximum number of unique substrings found during all of our recursive calls. So now if we run this, passes our test cases, and if we submit it, passes all solutions. So that's it. We successfully solved our LeetCode number 1593 using backtracking. This problem is a great example of how recursion and backtracking help us explore all possible solutions effectively, and hopefully you learned something from this problem. Thank you, and follow for more daily LeetCode problems.